let's look at how we can use Excel to do the heavy lifting when it comes to solving linear programming problems. The tool we'll use in Excel is called Solver. It's under the Data tab, and I've got it under here, Solver Analysis. If you look at your version of Excel and do not see Solver available underneath there, under the Data tab, what you would need to do is go to your File tab, go to Options, click on Add-ins, and then down here at the bottom where it says Excel Add-ins, click Go, and then check the Solver add-in box and click OK. And then you should, again, under the Data tab, have Solver available. It's a great tool. Okay, so what I've got here on my page is roughly what we did in our last video. We've got the profit equation, $2 per algebra student plus $1.25 for each arithmetic student. We have our constraints due to our computer hours and our tutoring hours down here. And what we want to do is translate all of this information, which is in something we understand, into something that Excel is going to understand. So again, with Excel, it doesn't really understand variables, it understands cell references. So I'm going to pick a couple of cells to be my variables. And what I usually like to do, just to make them pop out a little bit, is put a box around them, add some color to them, and I'll just throw in a couple dummy values, 1 and 1. So 1 algebra student, 1 arithmetic student. Now I'm going to translate my profit equation and computer equation, or constraint equations, into equations with cell references to these two cells. So my profit equation is going to be a formula, so I'll start with equal, and it will be 2 times my x plus 1.25 times my y. And if I have 1 algebra student, 1 arithmetic student, I'll make a profit of $3.25. Now my constraints, again, they'll be formulas, so we'll start with an equal sign, 2 times x plus 1 times y. And that's all I'll put in this one cell, just the left side of my equation. And then my other constraint equals 1 times x plus 1.5 times my y. Again, just the left side of the equation is going in there. And then this will also be a note to myself that both of these are going to be less than or equal. And then what I want them to be less than or equal to, my constraints, 300 hours of computer instruction time I have available, and the 200 hours of tutoring time I have available. Okay, there are 2 other constraints to this equation, x greater than or equal to 0 and y being greater than or equal to 0, but I can take care of those 2 constraints in Solver. So I'm going to go to my Data tab. I'm going to pull up Solver. Let's see if I can slide it over here and make it a little easier to see what I'm doing. So the first cell is my set objective. What am I trying to do? What I'm trying to do is maximize profit. So I want my profit equation here, and I want it to set to maximize. And then my variables apparently are already selected. So let me delete those, and delete those. Okay. All right. So my objective is trying to maximize profit by changing these 2 variables subject to these 2 constraints. So I'm going to go to add a constraint. I need this cell to be less than or equal to that value. And then add in my second constraint. I want this cell to be default to less than or equal to that value. And okay, so I've got both of my constraints in there. And then as long as I have this box checked, make unconstrained variables non-negative. If I check that, that takes care of my x greater than or equal to 0, my y greater than or equal to 0. Basically, I'm saying, yes, negative variables make no sense in this problem. Make them non-negative. And then I've got some options on solving method. These are going to be linear equations. You need to check the simplex LP. Be a little careful there. It defaults to the nonlinear solution, and we want the linear solution, simplex LB. And then we just click on solve. It asks us if it likes a solution, and we can say yes, and that's the solution we got before. Our solution, we will maximize our profit. With 125 algebra students and 50 arithmetic students. And we can make that look a little prettier. Merge center, wrap text, put a border around it, maybe put some color in it so it pops out there. Okay. I think you'll agree with me that's a lot easier than drawing our constraints, finding our points of intersection, checking all our corner points. Solver's a lovely tool in Excel. But that is not all it will do. Something else it will do is a sensitivity report. So let me run Solver again and show you how to bring up the sensitivity report, and let's talk about what it does for us. Set a Solver. Everything, it remembers everything I did, so that's nice. I don't have to type it all in again. When I click Solve, what I want to do here is check the sensitivity report and click OK. Now nothing's changed on my solution, but if you'll notice down here I've got a new tab, a sensitivity report. Let me click on that. What the sensitivity report does is give us an idea of, well, two main things. It gives us an idea of how much we can tweak our objective coefficients in our problem were the 2 and the 1.25. We were getting $2 profit for each algebra student and $1.25 profit for each arithmetic student. The sensitivity report tells us how much we can tweak those numbers and still have our final solution, 125 algebra students and 50 arithmetic students. How much we can tweak these values without these changing. So if we're happy with 125 algebra students and 50 arithmetic students, but we've got an option to either raise or lower our profit a little bit on our profit function, this gives us an idea of how much we can change it before that solution will change. Basically, this is how far we can change the slope of the profit isolines until another corner is the optimal solution. So I find this easier to understand if I play with the numbers. Right now for my algebra students, my optimal solution is 125 algebra students when I'm earning a profit of $2 per algebra student. And then I've got an allowable increase here of 0.5. If I change the objective function, if I increase it by up to 0.5, this will still be my best solution. If I increase it by more than 0.5, the solution will change. So let me come over here, click in the profit coefficient a little bit. If I change my profit coefficient, right now it's at $2. If I change it to $2.49, so my allowable increase was 50 cents, I'm going to change it just a little bit lower than that. Hit enter. Run Solver. My solution hasn't changed. It's still 125 algebra students and 50 arithmetic students. If I change that to $2.51, raising it above the allowable increase, and run Solver again, my solution's changed. I've made the profit on the algebra students attractive enough that the slope of my profit isoline has changed, and so now the corner point of 150 algebra students and 0 arithmetic students now gives me the highest profit. Is that what I want to do with my business? It might be, it might not. That gives me an idea of how much I can change things. So again, going back to the sensitivity report, It's how much I could increase this particular coefficient and still have this and not have the solution change. Or I could be looking at my arithmetic students. What if I think I can get a higher profit, raise my revenue function, and get a higher profit on the arithmetic students, how much I could change that and still keep this particular product mix. I would think that for this particular business, it would be good to have this corner point would be the best profit mix because I've got both algebra and arithmetic students. I've got some variety to my business. Now, the other thing that the sensitivity report tells us is something about shadow price that I think is pretty interesting. So the shadow price, a different color pen, are these two values here. The shadow price refers to the constraints. I've got a constraint of 300 hours on my computer resource time and 200 hours on my tutoring time. The shadow price is how much my profit will go up if I can get one more unit of a particular constraint. So I've got 300 hours on my computer instruction time. The shadow price tells me that my profit will go up 87.5 cents if I can get one more unit of computer instruction time. So we come over here. If I change this constraint from 300 to 301, run solver, oops. Okay, run solver. I now have a profit, get my pen back here, of $313.38. Before, I was getting a profit of $312.50. So my profit's gone up, $312.50 to $313.38. It's gone up the 0.875 for one more unit. Let me try that again. Okay, so right now on my I've got 200 hours of tutoring. I've got a shadow price of 25 cents on my tutoring. If I could get, say, another 10 hours of tutoring, how much will my profit go up? So the extra 10 hours of tutoring times the 25 cents should mean my profit goes up $2.50 from my original profit. My original profit is $312.50. Another $2.50 they get me up to $315. So they come over here, set this one back to 300. Add another 10 hours to the tutoring time. Run solver. And we're getting the profit at $315. So now if they can get 10 more hours of tutoring and make it, how much do you think 10 more hours of tutoring would cost my business? Probably more than $2.50. So that's all the increase I'm going to see my profit. Hiring 10 more hours of tutoring is probably not going to pay for my business. So again, the sensitivity report's got a lot of interesting information, but I had to play around with it quite a bit before it made sense to me what exactly it was telling me. So play around with yours, see how that looks. And again, you're going to like Solver. It saves you a whole lot of work on the paper, a whole lot of drawing lines, finding points of intersection. Enjoy.